And hello, welcome back OpenFoamers. Today we want to talk about looking at the individual operations in this all run pre case for chtMultiRegionSimpleFoam. Alright, so we have run the all run pre and these are the logs that have come out. So we want to take a look at how these things run individually so that we can understand them better. So what I'm going to do is I want to copy this multi-region heater. Okay, or rather let's me go to the GitHub, GitHub workspace, and yeah, let's put it here and let's make a directory called chtMultiRegionFoam. Okay, so for both SimpleFoam and PimpleFoam, we'll go there. Yeah, for both SimpleFoam and PimpleFoam. So chtMultiRegionFoam, you should either use PimpleFoam or PiezoFoam, but PimpleFoam should be preferred. So I want to copy. All right, I want to copy this directory here, this multi-region heater radiation here, CPAR. All of this, and put dot here, so that you'll copy and paste it to this directory. And I want to copy one more copy. Copy multi-region heater. Why do we want to have a copy? So we have a copy we can mess around with. All right, so let's go to multi-heater radiation here, and let's go to CHT and the copy file here. So I'm going to clear both sides. I'm going to list the options out. All right, so we want to clean all this up first, so we can do it step by step. All right, let's take a look at the all run pre. All right, oopsie. VI all run pre. All right, so first thing first, we have block mesh and toposet. How are they run? We can take a look at block mesh. VI log.blockmesh. Okay, so they just run block mesh first. So let's do block mesh, and then we go to blockmesh.log. So that should be able to clean it up. Oh, before I start, oh yeah, I already cleaned it up. Okay, that's good. Yeah, before I start, you've got to clean it up. Do that run and all clean so that we have a clean file to start with. So first thing we want to do is block mesh, and you go to blockmesh.log. All right, so that's done already. You can look at blockmesh.log, and you should see this is exactly the same. Okay, nothing too interesting. Okay, so what happens before and after? We take a look at constant, and we see there's a polymesh there, and these are the files generated by blockmesh. Okay, clear. And then next thing we want to run is let's see, toposet. Right, let's see the toposet. Okay, so what they do, they just run toposet as is. So toposet going to toposet.log. So nothing too interesting, it's just going to make cell zones. All right, so next thing after that, okay, topomesh and block mesh, toposet and block mesh you should be pretty familiar with. So next thing we run is restore zero directory. Okay, which basically is a CP AR of 0 original to 0. That's restoring zero directory. There's nothing more to it. So you take a look at 0, you just see the default things down there. Okay, so what is next? We need to do splitMeshRegions. All right, let's take a look at the log splitMeshRegions. And how do they do it? they say splitMeshRegions cell zones override. Okay, but not going to do that straight. Let's run it the default way, just that we can, just so we can see what happens if we run it like that. Okay. All right. So if we do it like that, this is what comes out. So the build is OpenFoam, blah blah blah. It's going to create some mesh, mesh for time equals 0, creating a single patch per region interface, trying to match regions to existing cell zones. So you have to split up the cell zones first. So writing a region per cell file, and it will be in the constant cell to region. Okay, that's clear. So it will be in a constant cell to region. So let's see constant. Excuse me. Let me sneeze a while first. So sorry about that. Apologize that I'm getting a bit of a cold. I think maybe. I don't know. I should get more vitamins or something. Anyway, as long as it's not too strenuous, I'll continue the video. So okay, this is cell to region. Hold on. Yeah, this is cell to region, and then this is just 3,000 cells in one region called region 0. Okay, so that's nothing too fancy about that. And if you take a look at CD0, nothing is changed. Okay, so let's take a look at the splitMeshRegions again. And what is the next thing? Okay, so we need to split up splitMeshRegions by cell zones. So let's see system. Oh, okay, should be in constant. Sorry. Well, before I do that, I want to take a look at the cell to region file if it's run properly. Okay, so there's 3,000 of these. So I'll go all the way down to the bottom. Okay, so there are 3,000 cells. And then for each cell, they'll tell you what region it is, from 0 to 4. So this is how it is like. So in this case, we have the cell to region. Okay, constant cell to region. Everything is 0 because it's just one region. Okay. So let's try running it with the cell zones. Okay, so let's split mesh regions cell zones. Okay, so what does this do? It quickly maps everything. So okay, it's running again. And based on the number of cell zones, we have 5 regions. So writing region per cell file to this cell to region. So this is how it's being done. And it writes the region per cell as a volume scalar field to this cell to region in the 0 directory. Oops. Okay, clear. CD0, and you see cell to region. And this is how it's being done. And we take a look at this. We have a 1 directory here. So this is where all the new stuff is being written. It has its own polymesh. It has its own G, T, U, blah blah blah. So based on the how you split the mesh, based on the cell zones, it starts splitting everything up, and then it writes to the 1 second file. Okay, so let me clear. So the reason why we have to specify cell zones is that since we already made the cell zones using toposet, we will need to designate, okay, I want to split the mesh into certain regions. So you see the region 0, 1, 2, 3, and 4 based on the cell zones that we have configured using TopoSet. So TopoSet, you should be familiar. So this one is just splitting it up into regions. All right, so let's try running it with the override function. So I'm going to do splitMeshRegions, cell zones, okay, and override. So I can tap to finish it up, and this is how it's being done. And now if we take a look at 0 and we list, we can see that every of these files are now written in the 0 directory. Okay, so all these files are written in the 0 directory, and the 1 directory is basically redundant. Okay, so that's what running this actually does. So when we specify splitMeshRegions, you have to specify splitMeshRegions using what metric. So in this case, it's cell zones. So we can take a look at the splitMeshRegions inside some OpenFoam wiki, for example, this one. And okay, let's open this in a new tab. Open this in a new tab. So okay, and this is the API guide. All right, so this is using the OpenFoam ESI version. This one is I think OpenFoam Foundation, based on version 2.1, a very early version. In fact, when we take a look at the v1906, right, the files, I mean before the two versions of OpenFoam actually split up, we can take a look. You see, the foam file is a version 2.0. So basically at version 2.0, the OpenFoam actually splits up into two different branches. Okay, so at 2.1 is pretty similar to the 1906 in that sense. So they came from the same root. And that's just yeah, how things actually turned out. All right, so it splits mesh regions with options. So it's basically splitMeshRegions splits the mesh into multiple regions, detected by walking across the faces. So each region is defined as a domain whose cells can be reached by cell face cell without crossing boundary faces, additional faces from face set, and any faces in between different cell zones. So the output is a volume scalar field, as we have seen in the 0 directory. All right, the volume scalar field is this one, I think, vi cell to region. So you see that it's a internal field, a volume scalar field. That's a class, which is a C++ nomenclature. Okay, it's a class. But if you're not sure, don't worry. It just means that, okay, it's a scalar field, and we have all of these data in there. All right. So, so we mesh multiple regions and map patches. So this splitMeshRegion is very good because it basically helps us to map all the patches between the multiple faces. So instead of you manually doing a block mesh, and then you try and split it up to here, and then you have to, you know, define all these faces, how the interaction is gonna be. What splitMeshRegion does is it just automatically says, all right, I have this face, and then I'm going to auto calculate these two faces for you if you so wish to split the mesh up. So it does that very nicely. Okay, so all right, so you can use cell zones. All right, patches cover the whole region. Okay, so these are the options. So if you want to output that volume scalar field, you use this detect only modifier, or else you use this face zone thing, mesh with multiple regions only. and then in mesh with cells and put into cell zones. So basically you can make cell zones using this split mesh regions as well, but if you're using TopoSet, it kind of doesn't really make sense to do that. Alright, so again, we have this blocked faces face set, specifies additional region boundaries that do not cross, blah blah blah. Okay, if you have this cell zone modifier, you split additionally cell zones into separate regions, which is what we kind of used. Cell zones only, split mesh into regions, do not use walking. I think that's there's this cell face cell walking. Again, I'm not going to cover that in this video. I don't think it's that important to know the technicalities of how this thing works. You just got to know what it's trying to do and how to use it. Unless the need so comes up that we need to try and understand what how split mesh region works, the algorithm. Don't think we need to do that. And let's see what are some of the other interesting options. It says override, which can override the existing mesh files, which is pretty helpful if we want to take a look at the constant. And then we see this over here. We see this heater, solid, left solid, right solid, I think. Yeah. Clear. Copy multi. Okay, let's do an all clean, and then I'll just quickly run block mesh. TopoSet. And then let's take a look at the constant and see before and after the split mesh regions. Okay. Okay, so this is the properties there. So restore. Okay. Let's restore 0 directory. And we run split mesh regions, cell zones. Okay, and override. So we take a look at system. Okay, we have all these things here. I think these were there by default. Constant, also there by default. Only thing is there's nothing in the 0 directory, so we need to do that. Split mesh regions and cell zones, override. Okay, so we have to map all the fields into here. So that's what it does by overriding all of this. Overrides the 0 directory. I think we already know that. Another interesting fact: you can run this in parallel if you so wish. Not an issue. Okay, so this is basically what to do split mesh regions with. Okay. So in the OpenFoam, the foundation version, they will be doing this heat transfer using chtMultiRegionSimpleFoam in the multi-region heater. So that's where it's being used, but ours is not quite the same. We have a SimpleFoam version, and then there's a chtMultiRegionSimpleFoam, right? Okay, cd foam tutorials. And we see heat transfer, and then we see chtMultiRegionSimpleFoam and chtMultiRegionSimpleFoam. All right. So these are the two. I mean, with a SimpleFoam, of course, you can do steady state a lot faster. That's the usefulness of that. Otherwise, it's pretty much the same as the chtMultiRegionSimpleFoam. So it's not chtMultiRegionSimpleFoam, but chtMultiRegionSimpleFoam. So it's the same for both versions. All right. So again, this is basically telling us the same thing, right? This is basically telling us the same thing, how to use, and yeah, there's nothing too fancy about that. Okay, split mesh. Okay, never mind. I'll just put this inside the description. So this is this is basically running the split mesh regions. So of course there are lots of other stuff that's going on. Lots of other things that are going on. in this case, and then okay, wrong one. OpenFoam Heat Transfer U2. Oops. And we take a look at chtMultiRegionSimpleFoam. Okay, clear. Oh, LL does this just for information. Haha. Okay, so let's take a look at the copy, or rather the multi-region heater radiation, and then we see the all run pre. So yeah, we've gone through these first 3 steps and we kind of try and understand what's going on. In the next step, of course, you're supposed to remove all of this from the region and processor. So and of course we have to run this change dictionary. Okay, so instead of running change dictionary 5 times for these 5 regions, you can use this for loop. Okay, you can use this for loop, and then it will do a it will run this change dictionary, which we can talk about in the next video. So in this video, we focus mainly on split mesh regions, and we explain some of the a little bit about how it works and what it does and how to use it. So at least using these 2 modifiers will help you to split your mesh. You split the simulation into several regions as dictated by a topo set, which makes the cell zones, and that's the input split mesh region takes in to generate all of this. So hopefully that helps you to understand what the split mesh region is about. We can take a look at change dictionary in the next video. Thanks for watching. I'll see you guys again next time. Bye bye.